This video is on drawing functions that have multiple parts. Now here I have a function that outputs x squared between -1 and 2. So that's here between -1 and 2. It outputs -2x plus 8 between 2 and 5. So that's 2 and 5 here. And it outputs -2 when I input anything between 5 and 6. So I need to draw this. Now I'm going to use different colors for this. I'm going to use blue for this section, so let's start with that. Now I should find what my output is when I input -1. So let's do that first. So if I input -1, so f -1, so when I'm inputting -1, I am using, so -1 falls into this inequality, so I need to use this for my output. So I need to do -1 squared. So I have -1 squared, and that is 1. So now I can plot that point, so I know when x is -1, my output is x squared. Also I should say that this is y equals f of x, here my axes, because I have y here. Now so when it's -1, I have 1, so -1 1, I can plot that there. Now let's try the other end of this. So the other end of this is 2. Now I know that 2 is actually in this place, but if I get really close to 2, like 1.9 for example, or 1.99 recurring, that's really close to 2. So I'm just going to use 2 for this now. So let's do that. So f of 2 is equal to 2 squared, which is equal to 4. So I know when I have 2, it's up to about 4. Also what you will notice in this function, that if I was to actually input 2, I would be using this. So let's try and see what that gives us. So if I actually input 2 in my function, I should be using -2 times 2 plus 8. This is just equal to -4 plus 8, and that's equal to 4. So I actually get the same point. I get the point 2, 4. Now for this first part, x squared, I can see that I've got 2 points here. Now I know the x squared graph won't be a line through there. So when I've got quadratics, I should be careful to see if my turning point actually lies between -1 and 2. Now I know the shape of the x squared graph, and I know the turning point is at 0, 0. So I should put that here as well. So I should put that there. Now I have 3 points that this first part of the graph will go through, so I can start drawing that now. So it's a curve going like that, and then up to there. Now the next part of the graph is between 2 and 5. Now I've already used 2 here using this output, so -2 times 2, so -2 times 2 add 8, and that gave me 4. So I've got this point already, and this is linear, so I only need one other point to draw this line, and I'm going to use the endpoint here. Now again the 5 actually goes there, so actually for this one I will use 4. So let's use 4. So 4 will be somewhere in between there, so let's use that. So I have f of 4. So when I'm using 4, that's between this one, so I'm going to use this. I did say I was going to use a different color, so I'll use green for this. So f of 4 is equal to -2 times 4 plus 8. That gives me -8 plus 8, which is equal to 0. So when I input, when x is 4, my output is 0. So let's plot that. So when x is 4, my output is 0, so it's here. Now I know there's going to be a straight line through these points, and it's going to go all the way up to 5, very close to 5, but not quite at 5. So let's just draw that line. And so it's going to go like that through there. So straight line through there, like that. Now I have the final part left, and this is between 5 and 6. Now I know if I input 5 or 6 into my function, my output's always going to be minus 2. So this is how I would write this. So if I was to, if I was to input, so input 5 into my function, my output is going to be minus 2, because in these inputs my output's always minus 2. Also, if I input 6, my output is also going to be minus 2. So when x is 5, my output is minus 2. So let's plot that. So 5 minus 2 is there. And also when x is 6, my output is minus 2. So let's plot that as well. X is 6 and my output is minus 2. It's there. So now I can just finish this with a straight line through there. And that is my function now. So my function between minus 1 and 2 is the graph of x squared, like that. The function between 2 and 5 is minus 2x plus 8. So it's something with negative gradient, and it goes through like that. And the function between 5 and 6 is just minus 2. So between 5 and 6 it's minus 2. Now you can see that the function joins up in all the points. Now sometimes it doesn't, okay, but for this course I've only seen questions where it does join up. Okay, so you don't have to worry about that too much. Now here we said that we used the 2 for the x squared. It actually gave the same value as the 2 gave here as well. And again here, if we had used the 5 here, we would have got minus 2. So it gave the same value, and this is why the graph connects together. So this is my graph. So the function is defined as fx is equal to x squared. So x squared between minus 1 and 2, minus 2x plus 8 between 2 and 5, and minus 2 between 5 and 6. And this is my graph for it. So x squared between minus 1 and 2, between minus 1 and 2. Then it's minus 2x plus 8 between 2 and 5. And then it's minus 2 between 5 and 6. Now here's another question that we can try and answer. So what would be the range of my function? Now the range of my function, so this is all the different outputs that I can get. So I can see the lowest output I've got, the graph doesn't go below this, is going to be minus 2. So I can start by writing my range. So my range f of x, the lowest is minus 2, which is here, and the highest point it goes up to is 4. So the lowest is here, and the range is all the way up to 4. So this is the range there. So minus 2 is less than or equal to fx, which is less than or equal to 4. So this is my range for this function here. Now here are some questions for you to try. So I'd like you to draw this function, and then define your own function that has 3 parts. So 3 parts like this, and the example above, where one part is quadratic. Now there aren't any quadratic parts here, but there was in our example. So one part of your example needs to be quadratic, and then you need to sketch it, and then you have to state the range of your function. So do that and then bring that to the lesson.